So our bell ringer today, page 574, number 14. Look at these two mineral samples. What property indicates that they may be the same mineral? Tyler?
The streak.
The streak. And I know this is something we didn't talk about yesterday, but it's going to be the first thing that we talk about today. But yes, it is the streak. So in our books, we have our streak test. This is when something, a mineral or a rock, is rubbed against a streak plate of unglazed porcelain. Some minerals leave a colored streak different from their original color. So this is our porcelain plate right here. This one is our white one. We also have a black porcelain plate. When you're doing your streak tests, always start off with this white one. We'll get into when we use this black one next. So on the board it says some minerals leave a different colored streak, different from their original color. Can I have a volunteer come up to streak test this mineral right here? Cash? When we do our streak test, we are going to leave it on our table and do it then. What color would we say that this would be just by looking at it? Black, gray, one of those two. Can you go ahead and test it right on here for me? Scratch it a little bit more. Okay, there's a good one right there. What color is that streak? Maroon, brown. Would you guess that the streak would be maroon or brown by looking at this mineral or rock?
No.
I would assume no. Because like we just said, it has a gray-black color. Cash, you may go sit down. And here's an example here up on the board too. This rock right here, we can kind of think about it as our gray-black one right here that's leaving a red-brown maroon streak. But, let's take this for example. What do you think this streak might be?
Black.
Black? Gray?
Gray.
Somewhere around there?
Gray.
Can I have someone volunteer to do this streak test? Annabelle? We have a lot of stuff that we can example today. So, go ahead and just do it right there. Okay, and what color streak is that?
Black.
It's black. So, thank you. There is a lot of times where the mineral that we had, it will show the same colored streak as what color that we actually see. But, like I said, just know that's not going to happen every single time. Also with streak tests, I want us to know that just because, let's say this one has a black and brown or gray streak, that does not mean that another mineral is not going to have that same streak. So it's very important when we do our tests tomorrow in our lab that you're not just basing the mineral's identity off of the streak or just the color itself, because a lot of them have the same ones. So in our book, we are going to underline the color of the powdered form of mineral. That is its streak. And make sure you box in streak there. Remember what I said, we have these two minerals up here. They have the same streak color. They might not be the same mineral. So don't just base it off of that. So we tested with our white porcelain plate. How about we test this mineral right here? Someone want to come up here and try that for me? Luke? Do it on the white one first. Are you seeing anything really? No? How about try it with this black plate? Now are you seeing something? Yeah. Yep, so with this mineral right here, and right here is talc, it actually leaves behind a white streak. So first, I always want you to test with this white porcelain one, but if nothing's showing up, try doing it on this black one. It might have a white color or a really light color. I have a volunteer that wants to streak test this one. Does anyone remember what this is?
Sulfur. Iron.
Sulfur. So if you come up here, you have to smell it, just so you know.
Ooh. Can I do it?
Ivy? So go ahead, take a nice whiff. Okay, now, try doing it on this one first. She's going to try it on the white plate. Okay, so try it on this one now. What is it showing? It's kind of white, kind of yellow. So like I said, if it's white, or if it has a really light color, try it on your black porcelain plate. Luke?
For the plates that you have, is there a way that you could like wash them off?
Just realize too that the plates that we have in our kit are going to be a lot bigger. So you'll have a lot more room to try on. So that's our streak test. The next thing we're going to talk about is special properties. It reads under special properties. All minerals exhibit the properties that were described earlier in this section. However, a few minerals have some additional special properties that can help identify those minerals. For example, the mineral magnetite is a natural magnet. The mineral calcite is usually white in ordinary light, but ultraviolet light, it often appears red. Another special property of calcite is shown below. And with this calcite image here, it's showing a double image of something. We can do that with this piece right here. But we're not going to test that today. So I have my magnetite right here, I believe. Well, I guess we'll find out when we test it. Do I have a person that wants to come up here and test this? See if it's magnetic. Trevor? Let's go ahead and hold that. And right here, I have my magnet. Can you go ahead and turn around so you're kind of facing the class? Now this magnet's pretty strong, so let's test. See? We'll do it again. Oh gosh. Yeah. So, right here it's showing that this is magnetic. It's kind of hard to pull off. But also see right here on the magnet, that magnet was so strong that it actually took off some of that mineral. So now it's just kind of powdery there. I'm sorry that not everybody gets to see. But here's another example, right here. This one's not as strong though. This is something that we're going to be using tomorrow in our lab. This is the only special property that we are going to be looking for. You do have a little magnet there in your lab kit. I'm not going to put the magnet on here because it'll be loud. But that's one of the special properties that minerals and rocks can have. Another one is it can be fluorescent. it says, some minerals absorb ultraviolet light and then emit light after the light is turned off. Minerals that do this are called fluorescent. So here's our before image, and here's our after, after it's been in a black light.
Whoa. Do it, let's do it.
So we do have some examples here. I'm going to pull out a couple.
Does it really go back that color?
You'll see. So let's look at this one first. What color is this one right now?
Yellow, white. I see.
Whitish, yellow, has a little bit of green in it, has some gray. Okay, remember that when we look at this one. What about this one?
Gray, white. Gray, white.
It's gray, has some brown in it, it's white. Okay, and then our last one. What about this one?
Gray.
White, silver,
It's kind
black,
of
gray.
gray,
Black, gray, white.
black, gray, white. So remember all those when we test them in the order that I just showed you. So first we're going to look at this one, which we said was white, yellow, some green. So I have my black light right here. Yes. I'm going to kind of go in here in the back because it's easier to see. But I'll walk around the rows. Do you see what that looks like, Braden? It's kind of yellow. Kind of looks green. Your stuff's right back there. See, it kind of looks like it's like those glow-in-the-dark stars that you can hang on your ceiling.
Oh, yeah.
I have those.
Or glow sticks.
I had those at my old house. The old look weirdo that. Oh yeah, the weirdo that still.
It's kind of neon.
Is this room? Possibly.
It's highlighter yellow.
Oh, yellow.
So you guys see over here? All right. So that's what that one looks like. Let's look at this one now. So this one right here, it's not as interesting. But you can see some orange on it. Yeah. It's kind of spotted with orange.
It looks like a.
All right.
Looks like a thermal.
So you thought that first one was cool.
Oh,
yeah.
This one's gonna be so cool.
Oh yeah.
Oh,
my God.
Whoa.
Looks like gold. Hey, let's orange.
Black.
Black.
Let's go down the rows with this one.
Gold. I like that gold. I used to have a really big one of those lamp things in my room. Black lights. Used to be my mom when she was dead.
I used to
She was young or something like that. I don't know what to say. She used to have one of those.
That's something you would have to ask.
My friend was like super creepy, so I
It's a
couldn't
golden.
It freaked me out. It made me think like, oh, that was.
So remember, it says that the reason why it does this, because I heard someone ask why when I was going around, it absorbs the ultraviolet light, which is our black light right here, and it emits the color that that was giving off. Is that pretty cool? Yeah. So,
Does every rock do that?
no, not every rock. Those are just some special properties. So, we have to kind of skip that video because it doesn't work right now. This next one might seem a little boring after with that fluorescent one, but some other ones can actually fizz if you were to put vinegar or hydrochloric acid on them. So here's, it says if you drop some vinegar on a rock sample, if it fizzes, then it can contain calcium carbonate. So I have a video that's actually going to show us how that works. But in this video, they're going to be testing with acid. That is something that we are not going to use. If we were going to test for fizz, we would be using vinegar. If you're testing for fizz, usually you use hydrochloric acid when you're in high school or college. I used hydrochloric acid when I was testing for rocks in college just last semester. But hydrochloric acid can actually kind of burn you if it touches you, so that's why we're not going to use it. It's really small dose, it kind of just tingles, but we still don't want to mess around with it. But here's two examples of a fizz test. He's using two rocks. One of them is called calcite, and the other one is called dolomite. Oops, sorry.
This is a cleavage fragment of calcite, or calcium carbonate. As a hydrochloric acid is placed on the mineral, there is a rapid and vigorous reaction. This is a specimen of dolomite crystals on a dark gray rock, which is also dolomite. As the acid is placed on the dolomite, there is only a weak bubbling or reaction. Now, an area of the dolomite has been scratched to produce a powder. When the acid contacts the powder, there is a more vigorous reaction. The dolomite powder has a much greater surface area to which the acid can react.
Yeah, I know. Like I said, it's kind of boring compared to the fluorescent light. But fizz tests can be really important when you're testing at a higher level because, for example, in a lab that I was doing, I had two pieces of limestone in front of me. One of them contained fossils, the other one didn't. So that could help me out a little bit. But another way that I could determine which one was which was by doing that fizz test. If it reacted to the hydrochloric acid and fizzed, that means that it is one rock. If it didn't, that meant it was a different one. So fizz tests can be important. But like I said, we're not going to be doing that. One other test that I want to talk about that we are not going to do, people who are geologists, or if you're in a college class, tend to do this. Another thing that you actually can do is a taste test. I know, it kind of sounds gross. It's not really nice passing around a sample of a rock and seeing other people lick it and you have to. But I'll give you a scenario of this. My freshman year of college, I was taking geology, and I had two rocks. One of them was halite, and I don't remember what the other one was. But if you lick halite, it tastes like salt. So I decided I'm going to test this rock first. That was not halite. It tasted very bad. But then tasting the halite, it tasted like salt. There's some other things that you can do for that. You know those like salt lamps that you have, some people have?
Yeah.
If you lick those taste like salt. Those are rock salt. But I wouldn't advise just constantly licking that rock salt.
Why?
That'd be kind of gross. But that's another test that you can do. But again, we are not doing that one. The only one that we're going to focus on for our lab is if it's magnetic or not.
And metallic and non-metallic, right?
But we're looking at special properties right now.
Oh.
Okay.
So, we have all of the things that we need to test our minerals. So what we're going to do tomorrow is we are going to do a mineral identification lab. To start off tomorrow, we're going to be doing all of our tests. And we have a paper right here that has all the columns for our tests, the sample that you are testing, and you're going to write that all down. After you have done all the testing, On Monday, we are going to identify the minerals, which is that column right over here. How you are going to identify those minerals after you've done all that testing is we have a paper back there that have all of the answers to the testing, and then you're going to compare your answers to the ones on the sheet so that way you can get the correct answers. Some of them you might have to go back and check over your answers a little bit, but that's okay. We'll go around and check to see how you guys are doing, but I think that will be something cool that you guys get to do tomorrow. So, to review for our lab, we're going to go over this PowerPoint right here. And I want volunteers for this, because this is all stuff that we've already talked about. Don't volunteer yet, you don't know what the question is. Number 1, what are the 6 tests that we're going to be doing on the rocks tomorrow? We talked about 6. What are 6 tests? Think about 2 that we just talked about. Bryson, sit up, please. Jason, can you give me one?
Magnetic.
If it's magnetic, meaning that we're testing for that special property. It's another one. Addison? The streak. What about another? 4 more left to go. Jaslyn?
Fluorescent.
No, we're not looking if it's fluorescent. That's one of the special properties. Remember, we're only going to test for if it's magnetic or not. Ivy?
But if it can be scratched, what?
Okay. What did we call that test, though? If it can be scratched. The hardness test. Another? Annabelle?
The black light.
No, not the black light test. Tyler?
Luster.
The luster. What are the 2 types of luster that we're looking for?
Non-metallic and metallic.
Non-metallic and metallic. Braden?
The taste test.
No, we're not doing a taste test.
Make hard test.
Amy? No, we're not doing fizz test. 2 more. We talked about these yesterday. What was the first thing that we talked about yesterday? Trinity?
Color?
Color.
Oh.
We have 1 more. 1 more.
Hardness. Weight breaks.
The weight breaks. What did we call that?
Cleavage and fracture.
Cleavage and fracture. So those are the 6 tests that we're going to be checking for. We have our color, streak, luster, cleave and fracture, hardness, and special properties. Why is the color of a rock not very reliable? Why is it not very reliable? Trevor?
For example, iron, carbon, and gold are the same color.
Mm-hmm.
So, lots of materials are the same color.
Okay, so a lot of minerals can be the same color as other ones. Why else? Luke?
Because the picture you showed up there that had the 2 rocks that had the streaks, and they're the same color, but the rocks were different colors.
Okay. I'm looking for something else. Think about the quartz that we looked at yesterday. Think about the quartz. Trinity?
The color can change.
Color can change. So, with our minerals, the same rock or mineral can be the same, but they can have a lot of different colors. That's why I said think about our quartz from yesterday. Remember, with our quartz, we had pink, which was called rose quartz. We had purple. That was our amethyst quartz. We had our brown, and we had yellow, green, and we had a black one.
Smoky quartz.
That was smoky quartz. All of these quartz are the same, but they all have different colors. So that's why the color is not always very reliable. Another reason why the color might not always be reliable is that rocks can be dyed bright colors. So right here, these are the same, but Nevaeh, can you tell me what's different between these two? Yeah, so on this one right here, we see that there's black in it, but this one over here, there's not. This one has been dyed. So while they're the same, one of them has been dyed, so that might sway some people's opinions. How do we perform a streak test? Can someone tell me the answer and come up here and show me? Cash?
Like I don't know, it's hard to explain.
Okay. Can I have someone try to help him out? Nevaeh? Yeah, so we take one of our rocks with this porcelain plate and we scratch it. Can someone come up here and show me? Mason? I'll have you do that one. Okay? Then try this one. So that one wasn't showing up, so what do we need to do next? Yes. Alright, thank you. So first, Mason, he left his porcelain plate down on the surface of the table. Make sure you're doing that because, like the glass, if we hold these in our hand, we press really hard down on them, they can also break. So for this first one, he started off with the white porcelain plate. That worked out. But this sample right here, he started out on the white porcelain plate, didn't show up, so then he went to the black porcelain plate. Which color tile do we always start with for the streak test? What color tile do we always start out with? Damien?
White porcelain.
We always start out with a white porcelain plate. Why would we need to use the black one? Why would we need to use the black one? Coda? What? Someone want to help him? Nevaeh? Yeah. So if the color does not show up on the white one first, it might be either a white streak or it could be a very light color. So that's when we go to the black tile next. What two types of luster are we going to be looking for? Can I have someone tell me one and then come up here and grab an example of that? Michaela? Metallic, can you come show me a metallic one? Yeah, this one's metallic. What did we say this was?
Pyrite.
It's pyrite or fool's gold. It's also called pyrite. What's another one? What's another type of luster that we're going to be looking for? Jeremiah? Non-metallic, do you want to come up here and grab an example? Yes. Yep, this would be a good example right here. Thank you. You may sit down. Do you remember what this one was?
Fluoride?
Yes. Fluoride. But this is an example of a non-metallic. Are all shiny rocks metallic?
No.
Can I get a raise of hands, please? Are all shiny rocks metallic? Braden?
No.
No, they are not. I'll show you an example right here. Right here. You see that shiny, right? That doesn't mean it's metallic though. Metallic needs to have colors that are similar to that of metals, like our pyrite right here. But this one that I have in my hand, this is called obsidian. Obsidian. Obsidian is volcanic glass. So, it's, if I were to drop it, it would break like glass. So, Amy, can you go ahead and touch that for me? Cash, touch that. Anybody else in this row?
Can I touch it?
Oh, I didn't know. Can I touch it?
Really quick, really quick, really quick.
So shiny.
Diamond, scissors, jewelry. I'll go down these.
Oh, yeah.
And also touch that one.
Why are you causing that the same reason as the other thing that one?
Yep, this one is also obsidian. So, like I said, obsidian can also be called volcanic glass. Focus back to the front, please.
What's volcanic rock?
Volcanic rock, there's a lot of different ones. And we'll get more into those when we go to the rock cycle. So, volcanic glass. Just quiet down for a second and listen. What does it sound like when I do this?
Glass. Knives. Knives.
It kind of sounds like I heard two plates rubbing together. You can also think of it as maybe like two glass jars hitting one another. Anything